Hello, everyone. Have you ever wondered if and how better data can lead to better buildings? My name is Martin Röck, and I'm here today to speak to you about our vision for a global building data initiative for reducing resource use and whole life carbon emissions of buildings globally. The background of this work is the Global Consensus on Sustainability in the Built Environment. It's an initiative of the 6 leading international construction engineering associations that have come together under this banner of GLOBE to work towards sustainability in the built environment. And they're also hosting the initiative that I'm presenting to you today. But let me start by giving you a quick context on whole life cycle greenhouse gas emissions in buildings. There are different types of carbon or greenhouse gas emissions of buildings. The one that is most known are the so-called operational carbon emissions that arise due to the use of energy, water, also building-related mobility during the use phase of buildings. But then we also have so-called embodied carbon emissions. Those emissions linked to material production and processing as well as transport of materials. They occur for the initial extraction, transporting and manufacturing, so the production of materials, but then also at different stages of the life cycle for the transport to site for the construction installation process, as well as for maintenance, replacement or renovation during the use phase, and obviously also at the end of life, the deconstruction process and post-processing of materials. And here I want to clarify, when we talk about whole life carbon, we often really mean greenhouse gas emissions. Certainly when I speak about it here, I'm talking about greenhouse gas emissions, which are usually expressed as CO2 equivalents. The built environment in that regard is really a global challenge. We know that around 40% of the global anthropogenic greenhouse gas emissions arise from building construction and operation. Out of those, 50 to 90% of new buildings emissions are related to material production and processing. So that's really why the new building construction matters so much. We know that around 40 tons of CO2 equivalents occur upfront, so for the production, the transport, and the construction process of new buildings, for each 100 square meters of new buildings built, 40 tons. And again, in here, the building structure makes up for the majority of emissions. It's usually around 2/3 of those emissions that are embodied in new buildings. So it's really a substantial share that we're talking about here. Let me quickly explain to you how we conduct life cycle assessments of buildings. So the assessments behind these analyses. I like to distinguish two main things. The spatial dimension, where we talk about products and processes. From a building's perspective, this usually means that we describe the materials that are used in the building, and we often do it in a hierarchical way, where we describe materials used within elements, within buildings, and then those buildings within cities or within national building stock. So we really make this spatial allocation and describe the characteristics and the quantity of all those materials and processes. Then we have the temporal dimension, where we are trying to really capture the whole life cycle of buildings. This means different life cycle stages in our international norms. We usually have the nomenclature where A is the production stage and the construction installation process. B is the use phase, where, as I said before, we have building operations, so the operational energy, but we also have the embodied emissions of replacement, refurbishment, and so on. And then the C stage is the end of life with all the processing that goes on for deconstruction and eventual end of life treatment. Now, the steps of an LCA calculation are really to take the list of these activities, these products and processes, and calculate based on the different life cycle stages and the different scenarios that we assume for future life cycle stages, the so-called life cycle inventory. So the combination of activities and life cycle assumptions, life cycle scenarios makes up the life cycle inventory. That's an extended list of activities that we then multiply with the indicators, with the impact factors related to different indicators. Now, when we talk about greenhouse gas emissions, these are, for example, emission factors for the embodied emissions of 1 kilogram of concrete during production. And then that gives us really the LCA results. It sounds really straightforward, but certainly if you do it for complex product systems like buildings, and if you do it for a variety of environmental indicators, this calculation can be fairly complex. Also, there are different ways of doing LCA. You can do static LCA, you can do dynamic LCA, attributional or consequential, all types of flavors with different use cases. So an LCA always depends really also on the goal and the scope that is defined up front that informs how to interpret the results. And usually LCA is also depicted as an iterative process where the interpretation of a first assessment might lead to a refinement of the goal and scope and another iteration of the whole process. At the building level, I've already briefly mentioned it before, we know that embodied greenhouse gas emissions are of increasing importance. We could show this in a global meta-study that we've published a few years ago, where we could really show, as you can see on the left, that overall, the red part, the embodied emissions, and the blue part, the operational emissions, have decreased due to our success in improved energy efficiency of new buildings. So overall, the whole life carbon emissions show a declining trend. However, at the same time, we see that the red part, and certainly the relative share of embodied carbon emissions, so this dashed line, is on the rise. And we know that today, 50% or more, 50 up to 90% of the life cycle emissions of new buildings are embodied emissions related to material production. And there is an important distinction in the way that operational emissions are emitted and the way that embodied emissions occur. Because operational emissions are somewhat reoccurring regularly each year of the building life cycle. They kind of accumulate over time in a more or less regular way. On the other hand, embodied emissions, the red part, you can see they occur in spikes. So you have a big chunk of embodied emissions occurring at the very beginning for initial material production. Then again, for the replacement later during the use phase, and then at the end of life. If we look at this on a timeline, so the horizontal axis here is really the timeline from 2020, in this case, 50 years into the future until 2070. We can see also how this correlates with the climate targets that we have. We've set the ambition to stay within 1.5 degree or at least below 2.0 degree of global warming, which means that we need to be net zero by 2040 or 2050, respectively. So in this context, this red upfront embodied carbon spike from material production is really dominating the picture because it takes 30 years and more before the red line and the blue line, so the embodied emissions and the operational emissions, actually break even. So for 30 years and more, new buildings upfront embodied carbon emissions, the material related embodied carbon emissions really dominate this picture and are therefore the main challenge. We like to call it the hidden challenge for effective climate mitigation in the building context. To better understand this phenomenon of embodied carbon emissions, we've been working on collecting data and establishing baselines and benchmarks in the European context. And we could do that, for example, for the life cycle related embodied carbon emissions per square meter, expressing it for different types of residential and non-residential buildings. And we've also done it per capita to better understand how the influence of different use scenarios influences the emissions per capita. So here we also have this aspect of sufficiency included, where it does make a difference if you're one or two people using a large single family house all by yourself, or if you're a small family living in an apartment in a multifamily building. So we succeeded in doing this for a variety of building typologies, as I said, spanning residential and non-residential buildings. At the same time, at the time of this study, also already a few years ago, we also uncovered that the data availability is still fairly limited, even in a region such as Europe, where we like to think of ourselves as fairly advanced on this topic. What we could derive is that there is really a need for joint action for decarbonization and the reduction of these whole life carbon emissions. Because when we look at where we are at the moment, the emission levels that we observed in this baseline analysis, and compare that with the global carbon budgets and their attribution to the building sector and to national and very specific building level targets, then we see that there is a real performance gap that we need to try and close as soon as possible. Because any further delay really increases the budget overshoot and also leads to a resulting carbon debt on the side of developed nations. So for this matter, we're really emphasizing the need for advanced data collection and emission reduction, and really for governments, industry, designers, as well as finance and investors to take action in their respective areas of activity. In the European Union specifically, there is quite a drive on the topic. Now, as some of you may be aware, we've recently seen a revision of the Energy Performance of Buildings Directive, the EPBD, which historically was responsible for driving the energy efficiency in buildings, so really promoting this. And now in its latest revision, it's also starting to include whole life carbon. And the roadmap, if it is amended in this way, really foresees that for new buildings that are larger than 1,000 square meters, whole life cycle greenhouse gas emissions, so global warming potential is the indicator here, needs to be disclosed from 2028 onwards. And from 2030 onwards, it needs to be disclosed for all new buildings, including for new buildings to comply with limit values that have to be set out in national roadmaps by the EU member states. And when we look at the situation on the topic of whole life carbon regulation across Europe, we see that many countries in Europe already have and require disclosure of whole life carbon, and they're getting ready to really regulate on it. Some frontrunner countries already regulate whole life carbon of new buildings with very specific limit values, which new buildings have to fulfill in order to get the allowance to be constructed. And again, for all of the countries across Europe, it means that by 2030, they need to have national roadmaps and whole life carbon limit values in place for both new and retrofit activities. And from 2032, we are even talking about a disclosure of a full life cycle assessment, which is not just greenhouse gas emissions, but really the full variety of environmental indicators. Beyond Europe, we've also been working on a global database, a global data collection on this topic of whole life carbon, also on the topic of material intensity and energy performance. And we could compile more than 1,200 building cases and describe them with more than 300 attributes that cover the context and the site, the building design parameters, inventory data such as the mass of different building materials, a documentation of the assessment methods that have been deployed, and then the results, for example, for the global warming potential for the greenhouse gas emissions of those buildings. And this database for us can really provide a basis for benchmarking in different use cases. It covers whole life carbon emissions per life cycle stage and for different building parts, and it includes information on the energy performance and the material intensity. With this database, we also published the open data collection protocols and scripts for processing and analysis. However, we know that we need advanced ambition to further develop the data formats and the analytics, and also to extend this open database. Because as you might have seen, there is still a lack of cases from global south regions. So what we want to do is to advance the database to gather more details and more cases and really work towards a global representation. And this is also where the Global Building Data Initiative comes in. GBDI, the Global Building Data Initiative, really works against this background that new construction is mostly occurring in the Global South. We know that until 2050, there is still a lot of new construction to be expected, but 90% of it will happen in regions of the Global South, not in North America, not in Europe. And we know that in those regions, it's also needed to do new construction for well-being, for ensuring a safe and just future. So we believe in order to enable a global decarbonization, we really need collaboration and aligned action and really work with partners in the Global South to ensure that together we drive decarbonization in the building sector. Because we've shown that better data can lead to better design and better buildings, and that there is tremendous potential already today. Research has shown us that we have 50 to 75% reduction potential for those embodied emissions of materials that is already possible today. And that includes, for example, the main levers of better structural design to avoid overspecification and avoid overspending on materials. It's improvements to enable better material production to improve, for example, concrete and steel. But it's also a shift towards adaptive reuse or low carbon material alternatives. For all of this, better building data is needed in order to understand where we are and reduce emissions effectively. So the Global Building Data Initiative really set out with a mission to leverage open building data and inform industry and policy action for reducing this duality of resource use and embodied and whole life carbon emissions of new buildings. And we do that through three aspects. We're working very specifically with partners in the Global South to really build a global network of key actors. We've been working with partners on a coordinated, open and scalable data protocol to enable alignment and open exchange of whole life carbon data of buildings globally. And we're working on an open source technical infrastructure for global data collection and analysis. All of these three aspects have been part or are part of the first phase of GBDI, which is currently ongoing and will run into 2025. Then in subsequent phases, we're looking into a global rollout for whole life carbon benchmarking and the identification of reduction strategies, and really the development of target pathways and supporting our partners in monitoring, reporting, and the verification of whole life carbon emission. The team behind this first phase is compiled of experts from EPFL Lausanne, from RISE in Austria, as well as partners in Brazil at USP and Denmark at Kongsgaard. We're very happy to work with a dedicated team, and I'm sure you are familiar with some of those faces already. To give you a quick overview of the activities of GBDI, I've already mentioned that we've been working on a global network of partners for establishing an open data exchange, transparency and comparability of LCA data. And here it's important to understand that what GBDI does is to move from the product level, product data, environmental product declarations, as some of you might know it, towards the building data level. So we are really concerned with understanding inventories at the building level. So we want to understand the material specification and the material quantities, and also where materials are being used in buildings. And we work with leading partners from the engineering and consulting space, as well as other tool developers or initiatives and organizations in the whole life carbon domain. Together, we've succeeded in developing an open building data format to have a common language for global building data exchange and analytics that can be used in both the one-directional or bidirectional way, and really enable design feedback also for building design or building engineering tools to enable a live benchmark comparison, target compliance, and also support hotspot analysis for identifying where improvements to a design can be most effective. Then we've been working on the Global Building Database Hub, which allows data management and visualizations. It supports benchmarking and lifecycle analytics. And most importantly, it's really an infrastructure that is open source and that has an open API, an application interface that allows also third parties to develop modules on top of the database and really enable integrations in custom tools and workflows. The database, the platform itself, is also customizable. It's set up so that we can incorporate customizable instances with different partners in different domains, may it be corporate, government, research or certification organizations. And we're working to support policy and practice going forward. And we have proud partnerships with different global, European, and also very local organizations to work on really improving consistency and comparison and help them really get started and move forward on collecting data and benchmarking and regulating on whole life carbon. GBDI's global network of partners really spans engineering, academic, and other institutions from around the world. As you can see here, we do have a focus on Europe and North America, but we're really also extending into regions of Latin America and South America, Africa, Asia, Southeast Asia, and Australia to really develop and grow this network into a global coverage and global representation. Together with our partners, we've also moved forward on developing an open data protocol that is easy to apply globally. We've conducted a review of existing schemas, mapping them against the space-time indicator framework to better understand the resolution that these different frameworks offer in terms of documenting and analyzing whole life carbon emissions per the building elements or sub-elements or materials that they occur in, and also the life cycle stages or the points in time that they are linked with. We have a technical report and a guidance document on the open building data format, the openBDF, as well as data upload templates and the data structure as JSON available. Currently, we're piloting the implementation with our partners in North America, the ECHO group, as well as with the Indicate framework in Europe. The Open Building Data Hub, the platform that we've been working on, is functional and currently hosts around 1,000 building cases with a goal to extend it into 10,000 building cases by the end of 2025. The database already now allows advanced analytics for benchmarking, for understanding also the emissions across a portfolio of buildings, always with the focus of understanding material specifications and material quantities to really identify where embodied carbon emissions are occurring in buildings and how they can be reduced and building designs improved effectively. In the next step, we are now starting to work with partners on customizable instances of the global building database hub. As I mentioned, this can mean integrations into the custom infrastructure that organizations already have. They can use and interact with our open source database and infrastructure that we've developed so far. Next for GBDI is to advance and conclude on this design and development of methods and tools that we've been working on now in phase 1, and then really focus on phases 2 and 3, the global rollout and the development of whole life carbon target pathways. At this point, we see 3 main tracks that we are pursuing for GBDI in parallel to maximize synergies. We will work to scale up, which for us means to work on global building stock modeling as a means to inform policy and industry leaders. This includes the work on a whole life carbon tracker to better understand the emission performance of buildings at the current time, but also in future scenarios. We will scale deep, that means the assessment methods to advance for prospective LCA of supply chain impacts to better understand where emissions are occurring today and in the future. And to scale wide, to foster global implementation through partnering with research, industry, and policy organizations, and really enable the implementation of the data models that we've been working on, the open source workflows and infrastructure, and really enable partners to pick that up and take the next step on whole life carbon analysis and regulation. And now this is my call to you. If you're interested in the Global Building Data Initiative, we invite you to join us. There are different ways of getting involved. You can simply sign up for the mailing list to stay up to date. We also invite you to consider joining the expert group to share your knowledge and learn from others. We're always keen to identify data partners that are excited to contribute data and co-develop the open data model through providing their feedback and really developing it together with us, as well as really specific project partners that have the means and capacity and interest to shape the future development of the Global Building Data Initiative with us together. So if that gets you excited, you can follow the QR code or just look us up online, gbdi.io. That's where you will find us. I thank you very much, and I'm here for questions if you have any. Looking forward to hear from you.